So today we're going to be doing the same thing I did in my previous video, but with y equal x squared. So let's start defining parameters. So this would be x equals 0, and this would just be the x value. So like I said in the previous video, we can think of the area under a curve as many rectangles, and then we can make those rectangles really, really small so that the representation becomes more accurate. So here's what we're going to do. We're going to do our lim as b goes to 0, and b is the base of all these individual rectangles. They all have the same base. It would be simpler for me to do it that way. So, all right. So what would be the area of this first rectangle here? Well, its position value is b. So if we plug in b into here, the height would have to be b squared. So its area would be b cubed. And for the second rectangle, it will also have a base of b, but slightly higher. But it would have a position value of 2b. So we plug in 2b, we get 4b squared. And therefore we'll have an area of 4b cubed. For the next rectangle, it will have a base of b, because I'm keeping all of these rectangles with base b. But it will have a position value of 3b. That means its height will be 9b squared, and so forth. Area of 9b cubed. That means if we sum all, we can sum all of these rectangles together to get something like the area equal b cubed plus 4b cubed plus 9b cubed dot dot dot, all the way until we get the last rectangle, this one here, will also have base b, but since its position value is x, it would have a height of x squared. And the last term will have an area of bx squared. Now, how do we relate x and b together? Well, if x is this entire distance from 0 to x, and b are these like tiny rectangles in between, that means x divided by b equal n, or number of rectangles. I'll let you think about that. So x is this total distance here, and b is just this mini value. So x divided b would be the total amount of rectangles. All right. So, all right. Now we can also do this. Let's factor out b cubed. So area would be lim as b approaches to 0, b cubed, 1 plus 4 plus 9 plus, and I'm just going to predict the next value, 16. This is the sum of squares, plus all the way to b cubed x squared over b. Wait, no, let me think. Okay, x squared over b squared, yeah. Because b over x squared divided by b cubed is this. All right, let's go to the next page. Now, as we said before right here, x over b equal n. And x squared over b squared would equal n squared. So we can do this. Lim as b approaches 0, area equals b cubed, 1 plus 4 plus 9 dot 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 plus n squared. And guess what this is? This is this summation. And I've done this in a previous video, and I proved what it was, but this equals let me think here. 2n cubed plus 3n squared plus n over 6. So now we have this. Now let's convert n back into x over b. So we get this. And let's distribute b as lim as b approaches 0. No, as lim as b approaches 0, this goes to 0, and this also goes to 0. So our final answer is the integral, or the area under the curve, is x cubed over 3. Now let's do it for y equals x cubed. Now I'm going to remain about it. The video got cut because I forgot what the sum of the cubes were, so I had to go online and search for it. But nevertheless, this is how you find y equals x cubed. We treat it as multiple rectangles, and I'm not going to go too in depth because hopefully you'll learn what I'm doing from the previous example. So a equal lim as b approaches 0, b fourth plus 8b fourth plus 27b fourth plus b cubed times, wait, no, not b cubed. The final value is x, so that means b times x cubed. We factor out b over 4 to get 1 plus 8 plus 27. Alright, so the area just equals x to the power of 4 divided by 4. Now I want you to notice the pattern here. So the area of y equals x squared is x cubed over 3, and this is x4 over 4. In my previous video, we proved that the area of y equals x is x squared over 2. Sorry, low battery. Oh, the area under the curve of y equals x squared is x cubed over 3, y equals x cubed, and finally y equals x cubed is just x4 over 4. And there's a reason for this, but basically with this pattern, we can break that the area under the curve x over 4 is x5 over 5, and so on. But now you guys might notice something. An integral is just a reverse derivative, because the derivative of x, derivative of x squared over 2 just equals x. The derivative of x cubed over 3 is just x squared. And that's something you should think about, because in my next video, I'm going to prove that an integral is just a reverse derivative. Thank you.